Hello, guys. All right, we're going to learn something new today. What we are going to learn today is very important. So I know I might say that pretty often, but today I'm very serious. The things that we learn today are going to be things that are extremely important when you're in 10th grade and especially 11th grade math. All right, so if you learn these things right now, when you get into the 10th and 11th grade, and even 12th grade, it will be much easier for you then. So I suggest that you listen carefully, that you try to understand. If you don't understand, please ask me questions. You can send me questions in Google Classroom or over our Discord group or anything like that. But make sure you understand what we are learning today. Okay, so let's start off with the definition. We're going to first start off with this definition, trigonometric ratio. Now, that's a difficult word to say, I know. Trigonometric ratio. All right. Now, trigonometric ratio, what is that? Well, let's start by looking at a triangle. All right. So over here, I'm going to draw a triangle. Just any triangle. Has to be a right triangle. So I'm going to draw a right triangle over here. Ooh, that's ugly. Let me start over. Let me try and do it a little bit nicer than that. Okay. Boom, boom, boom. Okay. So this is our right triangle. How do we know it's a right triangle? Well, let's say this is a right angle. All right. So we have a right triangle. Now, I'm going to also say let's say that the length of this side is 3. The length of this side is 4. And the length of the hypotenuse, the long one, is 5. All right, and we know that we can have a right triangle with these lengths because this is a Pythagorean triple. Remember we learned that? 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. So this is a Pythagorean triple. All right, so what is a trigonometric ratio? A trigonometric ratio is just the ratio, which means when we divide something, 3 divided by 5 or something like that. That's a ratio. All right, it's a ratio of two sides of a right triangle. So, for example, in this triangle, there are many trigonometric ratios. We could do 3 divided by 5, 3 over 5. That's a trigonometric ratio. Let me write it down. 3 over 5. That's a trigonometric ratio. We could do 5 over 4. 5 divided by 4. That's a trigonometric ratio. We could do 4 divided by 5. All right, and we could keep going. We could do 5 divided by 3, 3 divided by 4, 4 divided by 3. There's several different trigonometric ratios that we could look at here. All right, so that is what a trigonometric ratio is. It's just a ratio, which means we dividing 3 over blank. That's a ratio. All right, and so it's a ratio of two sides of the triangle. All right, so I'm gonna write that definition down real quickly. All right, I'm gonna write it right here. So trigonometric ratio is a ratio of any two sides of a right triangle. All right, that is a trigonometric ratio. I wrote ratio, ration. All right, a ratio of any two sides of a right triangle. So we pick two sides, and then we make a ratio with it. All right, that's all we have to do. That's a trigonometric ratio. All right, now I just said there are many different trigonometric ratios. We could do 3 over 5, 5 over 4, 4 over 5, or anything like that. But we give each of these ratios a special name. And today we're not going to learn all of the names. Today we're just going to focus on one of them. All right. We're going to talk about the tangent, which is a ratio. Sometimes we call it the tangent ratio. All right. Now, what is the tangent ratio? The tangent ratio is the ratio of the two legs. All right. So in the triangle, of course, we know that we have two legs and a hypotenuse. Well, if we make a ratio using the two legs of the triangle, then it is a tangent ratio. All right. So let's write down our definition here. So what is the tangent? It is the ratio of the two legs of a right triangle. All right. So that is our definition of ratio. Okay? All right, make sure you know that. All right? The two legs when we divide them. Now, for now, today we're going to skip angle of elevation. We'll come back to that tomorrow, all right, in our lesson tomorrow. All right? Today I want you to just focus on angle on these two, trigonometric ratio and tangent, all right? So let's go back to tangent. So what does that mean? The ratio of the two legs of a triangle. Well, the tangent is going to be 3 over 4, or it could be 4 over 3, right? Now, how do we know which one it is? Well, it depends which angle we're talking about. All right, so I'm going to again draw another right triangle. This time I'm going to draw it a little bit bigger because we're going to look at it pretty carefully here. So we have a beautiful right triangle. All right, here's our right triangle. All right, we know it's a right angle because I said it's a right angle. All right, so let's look at this angle right here. Well, we see here that there are two angles, right? One right here and one right here, and then we have our right angle. Now, these two angles are always going to be acute angles. They're always going to be less than 90 degrees. How do you know that? Well, think about it. This is 90 degrees. If one of these angles was bigger than 90, that would be 90 plus, let's say it's 91. 90 plus 91 is 181. Well, that's too big, right? You can't have a triangle with 181 degrees. A triangle's the interior angles of a triangle always add to 180 degrees. So that means this angle and this angle have to be acute angles. They always have to be less than 90. All right. Now, we can just pick one of them. Let's say this one, and let's give it a name. Let's say I'm going to call this A, and maybe I could call this B, and I could call this C. All right, and we are going to talk about angle A right now. Now, what we say when we're doing trigonometric ratios, and especially tangents, is what we will do is we'll say, what is the tangent of angle A? All right, and we usually shorten tangent. We don't write down the whole thing. We just write TAN. This means tangent. All right, so what is the tangent of angle A? Well, we already said that the tangent is always the ratio of the two legs. And let's say, again, that we know that this side over here is 3. This leg is 3. And let's say we know that this one is 4. Okay, so how do we know what the tangent of A is? Is it going to be 4 over 3 or 3 over 4? It could be either one, right? Well, the tangent is always the side opposite on top, all right? So the tangent of angle A is going to be 3, and then the adjacent side, that means the one that's next to it. Here's angle A. The side that is next to angle A, the leg that is next to angle A, is this one right here, which is 4. All right? So it's always going to be the opposite one over the adjacent one. All right? And it says that right here. All right? Let's look down here. It says the tangent of angle A is always the length of the leg opposite on top, and then the length of the leg adjacent on bottom. All right, so 3 over 4. That's the tangent of angle A. Now, we could also, let me change back to blue, we could also find the tangent of angle C. All right, the tangent of angle C. All right, how do we find that? Well, which one, let me change to a different color here. Which one of these sides, 4 or 3, is opposite C? All right, well, it's the one over here. This is opposite C. So now the tangent of angle C is going to be 4 over 3. All right, the opposite one over the adjacent one. All right, so we can find the tangent of angle A and the tangent of angle C. Now, right now, we can't find the tangent of this of angle B because it's the right angle. All right, we're only finding the tangent of the acute angles in the right triangle. All right, this is an acute angle and this is an acute angle. Okay, so I hope that's clear for now. We're going to do a few examples to see how to do this. All right, so let's move on to our exercises here. All right, so here we go. We have this triangle, RST, and it says find the tangents of the acute angles. So we need to find the tangents of all of the acute angles. Now, in each right triangle, there's going to be 2 acute angles. So you need to find the tangents of both of those, all right? Now, in this triangle, what are the acute angles? Well, it's not T. T is a right angle. R is the acute angle, and S is an acute angle, all right? So these are the 2 acute angles. So we want to find what is the tangent of angle R and what is the tangent of angle S. All right, that's what we want to find in this problem. Now, it's not too difficult. All right, just remember, what is a tangent? It's the ratio of the legs. Now, where are the legs of this triangle? Well, one leg is right here, and the other leg is right here. So all we need to know now is which one is on top and which one is on bottom. All right. Well, for angle R, remember the opposite always goes on top. It's opposite over adjacent. Opposite over adjacent. All right. So here is the opposite of angle R is 45 and the adjacent is 24. All right. So we have 45 over 24. And that is the tangent, right? And you should try to put it into simplest terms if possible. Now in this one, this is simplest terms, right? Because 45 is 9 times 5, 84 is 6 times 4, or 8 times 3. There are no common factors here. So this is the answer for the tangent of angle R. All right, now we want to find the tangent of angle S. Again, since it's tangent, we want to look at the legs, all right, 24 and 45. But which one goes on top? Well, it's the one that's on top is always the opposite side, all right? This is the opposite side. So that is going to be on the top. So the tangent of angle S is going to be 24 over 45. All right. And real quickly, it asks us to write each answer as a fraction and as a decimal rounded to 4 decimal places. All right. So if you want to do that, you're going to need a calculator. All right. So make sure you have a calculator ready. All right. So I'm going to quickly do that. So 45 divided by 24, all right, is going to be 1.875. All right. So this one is 1.875. All right. And then this one, if we use our calculator, 24 divided by 45 is going to be 0.533, and it goes on, but it says round to 4 decimal places, so we're done. All right, so these are the answers. All right, this is the fraction, and this is rounded to 4 decimal places. Now this doesn't have a 4th decimal point because this is exact. All right, so that's how you do this. All right, let's do another one. All right, let's do number 2 here. All right, I'm going to put a line just to keep things separated. All right, do number 2. We want to find the tangent of the acute angles again. So where are the acute angles? Well, we have angle J and we have angle L. So we want to find what is the tangent of angle J and what is the tangent of angle L. All right, now remember, again, when we're doing tangent, we just look at the legs. All right, so this is a leg and this is a leg. All right, we have the 2 legs. All right, 5 and 7. And to decide which one's on top, well, for angle J, remember the one that's on top is always the opposite one. All right, which is 7. All right, so it's going to be 7 over 5. All right. And we want to write it in decimal point form too, which is 7 divided by 5, and you get 1.4. All right. Oh, I should have been able to do that in my head. All right. So that's 7 over 5. That's the tangent of angle J. All right. Then we want the tangent of angle L too. Which one goes on the top? The 5. Now, because that's the opposite. All right. Remember, you can always draw an arrow from the angle to the opposite. You can't draw an arrow from L to 7, right? Because it's next to it, all right? So that's why I always draw this arrow to point to the opposite side. So 5 is going to be on top now. We have 5 over 7 is the tangent of L. So again, using a calculator, 5 divided by 7 is 0.7143. All right. And that is the answer. All right. And let's do the last one here, number 3. Again, we want to find the tangents of the acute angles. Well, this is an acute angle, and this is an acute angle. All right. And this is the right angle. So our legs are right here. This is a leg, and this is a leg. So we know that the tangent is going to be a ratio of these 2 sides. It's going to be 2 over square root of 2, or it's going to be square root of 2 over 2. Which one goes on top? Well, we're going to have to look at the opposite side. So tangent, we want to find the tangent of angle A. Let's do that first. What's on the opposite side? 2. All right. So we know that it's going to be 2 over the square root of 2. Now, real quickly, 2 over the square root of 2 is correct, but simplest form says that we never want to have a square root in the bottom, in the denominator of a fraction. We don't like that. It's ugly. So the way we fix it is we have to multiply by the square root of 2 over the square root of 2. All right? Well, that's just 1. Multiplying by 1 is okay. It doesn't change it, right? But it does change the way it looks. So on the top, we're going to have 2 times the square root of 2. And it's going to be divided by the square root of 2 times the square root of 2, which is just 2. All right? And now you can see this goes away. And what do we have left? Just the square root of 2. All right? Okay, so it's the square root of 2 up top. So that's the tangent of angle A. All right. Then we also want to find the tangent of angle C. All right. Tangent of angle C. Again, the top number is the opposite side, which is square root of 2. So this is just going to be square root of 2 over 2. And that's the answer there. Now we also want to write decimal point form. So I'm going to real quick do that. We got the square root of 2. And that equals 1.4142. And we have the square root of 2 divided by 2, which is 0.7071. All right, so that's the answer for those two. Okay, so far so good. Now, for the next part, you're going to make sure, you need to make sure that you have a calculator that is scientific calculator. Means it has to have, on the calculator, it should have buttons to do the tangent function. All right, so somewhere on your calculator, for example, I have a calculator on my phone that is a scientific calculator, and you can see down here, I don't know if you can see it in the video, but maybe not. Yeah, whatever. You can't see it. But down here, there's a button that says TAN. All right? And you need to make sure that you have a button on your calculator that says TAN. Okay? Now, because what we are going to do now is use that. Because remember, when I say tangent of angle R, that just means the tangent of some angle. It could be 30 degrees or 40 degrees or 25 degrees or anything like that. All right. So your calculator has the ability to put a degrees in here, like tangent of 30 degrees, and it will give you an answer in decimal points. All right. So we are going to use that now. All right. How are we going to use that? Well, let's see. We need to, in these problems, we need to find the value of x. All right. We need to find the value of x. Now, here we can see that x is the leg of a triangle. All right. And this 5 is the other leg. And we know that the angle here is 10 degrees. Well, we just learned that the tangent of this angle is going to be the opposite side, which is 5, divided by x. All right? So that means the tangent of 10 degrees, is going to equal 5 over x. All right? We know that because the tangent of the angle is always equal to 5 divided, or the opposite side divided by the adjacent side. Okay, so how does this help us? Well, now we can use our calculators, all right? I'm going to use my calculator right now, and I'm going to hit tangent of 10 degrees. And it gives me an answer. It gives me the answer 0.1763. All right, so that is the tangent of 10 degrees. But we already know that this equals 5 over x. All right. So now we can solve for x. That means x is going to equal 5 divided by 0.1763. And we can use our calculators now to do that. All right, we go 5 divided by 0.1763, and it's going to equal 28. And it says round to the nearest tenth, so we only need 1 decimal point, and this one is going to be 28.4. Okay, so that's how we do that. We use the tangent of this using our calculator. You have to use a calculator. There's no way to know the tangent of 10 degrees if you don't have a calculator. I don't think there are very many people in the world that have the tangents of all the angles memorized. All right, so let's do it again. All right, for this one we need to find x, and they tell us that this angle here is 64. Well, x is the opposite leg, right? We have this leg and we have this leg. So that means the tangent of 64 degrees is going to equal the opposite, which is x, over 13, the adjacent leg. All right? All right, good. So now, again, we can just use our calculators. We're going to say, what is the tangent of 64? Tangent of 64 equals 2.0503. All right, 2.0503. And that is going to equal x over 13. All right? So that means that x is going to equal 13 times 2.0. This is a 2. It's kind of ugly. 2.0503. All right. So we can do that now. X equals, and I'm going to do 2.0503 times 13. All right. And that gives us an answer of x equals 26.7. All right, which is what we wanted to find. All right. All right, and then the last problem that we're going to do today for practice is this one, number 6. Again, we have an angle here, acute. We know this leg is 24, and we want to find this leg. Now, 24 is the opposite leg. So that means the tangent of 31 degrees equals the opposite, which is 24, divided by x. All right, now we're going to use our calculator to find what is the tangent of 31. All right, the tangent of 31 degrees is 0.009. All right, and that's going to equal 24 divided by x, which means that x is going to equal 24 divided by 0.6009. Okay, and now we can use our calculator. 24 divided by 0.6009, and that gives us 39.9. All right, 39.9. And that's going to be our answer. Okay, so that's everything that we need to learn today. I'm going to give you guys homework assignments to help you practice this, all right? And tomorrow we're going to do more of this. We're going to learn how to do some word problems with these kind of tangent ratios, okay? So one other thing that I want you to know and make sure of is that your calculator probably has the ability to be in either degrees or radians. All right. Now, what are degrees and radians? I don't want to explain everything about it right now, but these are just two different ways of measuring angles, all right? Angles, all right? We can say that an angle is 30 degrees, or we could say an angle is 3 radians or 7.5 radians or something like that. They're just two different ways, but they are different. So you need to make sure, and every calculator is different, so I can't help you right now. I can't tell you what to do, but you need to make sure your calculator is in degrees, not radians, all right? Because if your calculator is set to radians, then when you do tangent 31 and hit enter, it's going to give you the wrong answer, all right? So I just did a few examples here. If you want to make sure that yours is right, why don't you click in your calculator right now? Why don't you hit tangent of 31 and see if you get something close to 0.6009. If it is 0.6009, then good. That means your calculator is set to degrees. If it's not, that means you need to set it to degrees. It's on radians right now. And you'll have to maybe ask me or send me a picture of your calculator so that I can tell you what to press. Because there is a way to switch it back and forth. Almost every calculator can do that. All right, that's all. I'm sorry today's lesson was longer. The video is a little bit longer, but we had a lot to learn and something very important to learn. So please pay attention and please work hard on your homework tonight. All right, bye-bye.